So often when we're dealing with area problems, we're often dealing with quadratic equations. If you notice that the area units are centimeters squared, okay, the squared indicates that the algebra that will go with it would be often a quadratic. So here we have a problem. The dimensions of our flag are such that the length is twice the width. Okay, when we can, we should often try to draw a picture of this. So I'm going to draw a picture of this, so where the length is twice the width. Now, what are the dimensions? That last sentence often indicates what your unknowns are going to be, or what your variables are going to be. So we don't know what the dimensions are, so we should let one of the length and widths be x. So I'm going to make the length, the height or the width be x, and I'm going to let the length be 2x, since it is double the width. Okay, so the length is twice the width. So here's my length, there's my width. Okay, and the area of the flag is 400 centimeters squared. Well, the area is going to be length times width. So in this case, the area works out to be 2 times x squared. And so our equation then that we need to generate is the area, 2 times x squared, is equal to the 400 centimeters squared. Here we have a quadratic equation. We could, since this is an x squared, we can undo a square. It's a perfect square. We could solve this algebraically, but since we are practicing using the quadratic formula, I'm just going to put it into the quadratic formula form that I can use. So it'll be equal to 0, and my a is going to be equal to 2, my b is equal to 0, my c is equal to negative 400, and I can solve this quadratic equation that way. So x is equal to negative 0 plus minus square root of 0 minus 4 times a times c all over 2a. Okay, so simplifying this expression, we get plus minus, this is going to, well, that's going to be negative 400, so we're going to end up with 8 times 400, so that's positive 3200 all over 4. Factor out the perfect squared. Okay, the largest perfect square factor looks like it's going to be 1,600. Okay, so then we end up simplifying this. So 1,600 square root is 40, so we end up with plus minus 40 root 2 all over 4. So that simplifies to plus minus 10 root 2. Okay, so we know that the x cannot be negative, so we'll get rid of the negative solution, and we'll say that the width is equal to 10 root 2, and the length is going to be double that, which is 20 root 2. Okay, so here's another problem where we have these are 2 house lots, it looks like. So Joe has a house lot here, and the house lot is 3 times the frontage. So here's the front, and the lot length is going to be 3 times that frontage length. So here's my front, what they call the frontage of the lot, and the depth of the lot is going to be 3 times that length, so we'll call it 3x. And Joe buys his neighbor's lot, so here's his neighbor. And maybe I'll just highlight that so that we can keep track of this here. So the neighbor's lot is going to be this area in here. Okay, so there's my neighbor's lot. And that has a frontage of 10 meters. And the depth of his lot, since it's his neighbor, is going to be the same depth as Joe's. Okay, so these are rectangular lots. This is maybe somewhere in Stevenson. So this gives them a total area of 1,100 meters squared. So what were the original dimensions of the lots? Okay, well, I know that the total area here, so the total area, which I'm going to highlight in red, this total area is going to be equal to 1,100 meters squared. And to get that total area, we have 2 parts to it. We know that this part, length times width of this Joe's original lot is going to be 3x squared. And we have to add on to it the area of Joe's neighbor, which is 10 times 3x, which is 30x. Okay? And so there's our equation. This area, these two area parts equals 1100 meters squared. We're going to make this equal to 0 so that we can apply the quadratic formula. Okay, and then plug it in. So the length, the original frontage x is going to be equal to negative 30 plus minus square root of 30 squared minus 4 times a times c, which is negative 1100. Okay. And that's all divided by 2 times a, which is 3. So we end up with negative 30 plus minus square root of, so this looks like it's going to be 900 plus, double negative, so it's going to be plus. 12 times 11 is 132 with 2 extra zeros. Okay, and then all divided by 6. So we get negative 30 plus minus the square root of, it looks like 141,000, or sorry, 14,100. Okay, so there's our radical part. We should simplify that. There's a perfect square factor of 100. So we get negative 30 plus minus. We'll factor that out, and we're left with 141, which we cannot square root. So there is our solution. Now we should simplify it with a common factor of 2. So it becomes negative 15 plus minus 5 square root 141, all divided by 3. Okay, so there's our solution. That we can get rid of the negative solution because that x can't be negative. So our solution ends up being negative 15 plus 5 root 141 all over 3. Okay, so this is a positive version of the solution. Okay, so this is the width, or the width of the lot. So this is width of Joe's lot. Okay, and again, I've just kept in the exact values, and I know that the reason why I can eliminate the minus version is because I start with a negative and I subtract. I'm going to have a negative solution. Here, if I start with negative 15 plus this number is going to be 5, is greater than 15, since we know that square root 141 is bigger than 3. Okay, so we know that this is going to be, this number 5 times this will be bigger than 15, so we're going to end up with a positive value for x.